Imagine sitting in a quiet room late at night. You type a question into a machine, and within seconds, a response appears. The answer is clear, structured, and strangely natural. It can feel as if someone, somewhere, has written it just for you. But there is no person on the other side. No thoughts. No awareness. No understanding in the human sense. And yet the words continue to appear. Sentence after sentence. Idea after idea. This is the quiet and unusual nature of large language models. They do not think the way humans do. But they can produce language that feels thoughtful and complete. Tonight we will slowly explore how this is possible. Not through hype. Not through speculation. But through a calm understanding of the ideas behind the technology. Because beneath everything, the system is doing something surprisingly simple. It is predicting what comes next. To understand large language models, it helps to begin with a simpler question. What exactly is a language model? A language model is a system designed to learn patterns in human language. Instead of memorizing definitions, it observes how words appear together across many different sentences. Over time, the system learns which words are likely to follow others. This process is based on probability rather than meaning. When humans read language, we connect words to memories, experiences, and emotions. A machine cannot do this. But it can measure patterns across enormous collections of text. Imagine reading millions of books and articles, not to understand their stories, but to observe how words tend to appear together. After enough examples, clear statistical patterns begin to emerge. This is the foundation of a language model. A system that studies the structure of language by analyzing patterns at a massive scale. Before a language model can analyze text, it must first transform language into numbers. This process begins with something called tokenization. Instead of reading entire sentences as humans do, the model divides text into smaller pieces called tokens. A token might represent a whole word. Sometimes it represents only part of a word. And occasionally it represents punctuation. Each token is assigned a numerical value. These numbers allow the neural network to process language mathematically. Inside the model, tokens become vectors within a high-dimensional space. Words that appear in similar contexts often end up near one another. In this way, language becomes a landscape of relationships. Training a large language model requires enormous amounts of text. Books, articles, academic papers, and websites all contribute examples of how language is used. During training, the system repeatedly performs a simple task. It tries to predict the next token in a sequence. If the prediction is incorrect, the model adjusts its internal parameters slightly. This adjustment process gradually improves the system's predictions. Over millions and billions of training steps, the network learns increasingly subtle patterns. Eventually, it becomes capable of producing coherent language across many topics. At the heart of every modern language model is a neural network. Neural networks consist of many layers of interconnected mathematical operations. Each layer transforms the information slightly. As tokens pass through these layers, their representations become increasingly refined. One of the most important innovations behind modern language models is called attention. Attention allows the model to consider relationships between different words in a sentence, even when those words appear far apart. This mechanism helps the system maintain context and generate coherent responses. The term large and large language model refers to the scale of the neural network. Modern models may contain billions of adjustable parameters. Parameters are the numerical values that allow the network to learn patterns. As models become larger, they can represent more complex relationships between words and ideas. This improvement through scale is known as a scaling effect. With more parameters, more data, and more computation, the system often becomes more capable. When people interact with language models, the responses can feel surprisingly thoughtful. The system produces complete sentences, structured explanations, and even detailed arguments. This fluency creates the impression of intelligence. Yet the underlying process remains prediction. The model selects each word because it is statistically likely to follow the previous ones. The result is language that appears meaningful, even though the system itself does not experience meaning. Recent developments have expanded the capabilities of language models. Some systems can now interact with external tools. The model may decide to search for information, perform calculations, or access software systems. This ability allows language models to solve more complex tasks. Instead of simply generating text, the system can interact with the digital environment around it. Despite their impressive capabilities, language models still have important limitations. Because they rely on prediction, they sometimes produce incorrect information. This phenomenon is often described as hallucination. The model is not intentionally misleading. It is simply generating the sequence of words that seems most probable. Understanding these limitations is an important part of using the technology responsibly. At its core, a large language model is a system that predicts words. Yet from this simple mechanism, something remarkable emerges. Language that flows naturally. Explanations that feel thoughtful. Conversations that resemble dialogue between people. In many ways, these systems reflect the collective patterns of human writing. A quiet machine learning from the written traces of human knowledge. And through this process, a new kind of interface between humans and computers begins to emerge.